Okay, here we go with problem number 16 on the college algebra practice final. This is a rational function. You're asked to sketch the graph. This is that one where we have that kind of laundry list of things to look for. We look for the discontinuities, whether those are holes. We look for those vertical asymptotes would be the non-hole discontinuities. We look for horizontal asymptotes, and then does it cross the horizontal asymptote? All these things are what we're going to be looking for. So let's just dive right in. If you notice, I've already got the original function. I've factored it, and I just think it's a lot easier. If you've got both forms, there are times when you want to use this original, and there are times where this just makes life super easy. So I factored the top. I just used the guess and check method. I knew it had to be 2x and x here. And the only two numbers that multiply to -1 are -1 and 1. So I just need to get those in the right place so that when I do my multiplication, I end up with a +1 in the middle here. So as long as I got that, I've got that factored. Of course, the denominator is the difference of two squares. So I get x minus 1, x plus 1. So that tells us our discontinuities . Our discontinuities are going to be, there needs to be an S, I think, in here somewhere. Yeah, let's do that. Discontinuities are going to be at 1 and -1. Okay? And are, these asymptotes, or are they holes? Well, with this factored form, 1 certainly makes this factor 0. Doesn't make this one, and doesn't make this one. So it only makes the denominator 0. So 1 is definitely a vertical asymptote. -1, however, these factors appear in the numerator and denominator, so when the -1 comes in this denominator, it also makes the numerator 0, and that makes this a hole. Okay, we're just going to file that away, and we'll come back to that later. Okay, so that takes care of our vertical asymptotes and holes, all the discontinuities. Now let's look at horizontal asymptote. For that, we need to go back up here to the original. We've got a second degree in the numerator, second degree in the denominator. They're the same. So we take essentially the ratio of those leading coefficients, 2/1. So horizontal is equal to 2. We might even write that as y equals 2. Okay? And now the question is, do we cross that horizontal asymptote? Okay, in other words, is there a value of x that allows us to equal 2, which means that we would have to cross it. So for that, we can go back to the original equation, or what I would like to do is simplify this equation. Go ahead and take that whole out, the x plus 1 over x plus 1. And if there's some way to make this equal 2, as long as the answer we get is not -1. Okay, if the answer we get is -1, then we don't cross. It's this hole coming back to sort of haunt us like a ghost, because holes do that kind of thing. So let's just go ahead and solve this. If I multiply both sides here, I end up with 2x minus 1 is equal to 2x minus 2. Those are going to cancel. So no, there's no value that makes that work. So it does not cross. Okay, so discontinuities, horizontal asymptote, don't cross the horizontal asymptote. Y-intercept. To find the y-intercept, we just put a 0 in for everything. And really, we can even ignore these again and just put a 0 in here. So 2 times 0 is 0, 0 minus 1 is minus 1. 0 minus 1 is minus 1. And that is equal to 1, so it's 0, 1. That is our y-intercept. So our y-intercept is at 1. Okay, let's see what we got. We got vertical asymptotes, holes, horizontal asymptotes. Do we cross x-intercepts? Let's see if we got any x-intercepts. We want to set the equation equal to 0 this time. Okay, we set it equal to 2 here. Now let's set it equal to 0. And again, I'm going to use the simplified. I'm going to pretend that that hole isn't there. And as long as our answers don't involve the hole, then we can kind of go with them. So let's just go ahead and solve this thing. 2x okay, if we multiply both sides by x minus 1, of course 0 times x minus 1 is 0, so 2x minus 1 equals 0, add the 1, and we get x equals 1/2. Okay. If we had done this with this equation, the original, we would have gotten 2 answers, and I have a feeling that one of the answers would have been at the hole and would have kind of messed us up. So let's just go ahead and go with this. X is equal to 1/2, so x-intercept at 1/2. Okay, I think now it's time to start putting what we've got onto a graph. Let's go ahead and do that here. So let's say we got a vertical asymptote at 1. What else do we got? We got a hole. Let's talk about that hole. We got a hole at -1. But remember, that's the x value. What is the y value? Well, the holes don't really have a y value because they're a discontinuity. But if we pretend that these guys are gone, we can put -1 in for the x here and here. And we can see kind of where it's going to go through, at least where to draw the hole. So we're going to put -1. 2 times -1 is -2, and -2 minus 1 is -3. -1 minus 1 is -2. So the point -1 doesn't exist, but it's a hole. It's where the hole would be if it did exist. So that's 1.5, so -1. We can just put a circle right there. And so we know somehow our graph goes through there. Don't know how, but somehow it does. Okay, let's take a look. What else do we know? Horizontal asymptote is 2. So let's go ahead and do this. Nope, you can't see that. Move it up. I put a horizontal asymptote at 2. And notice now we've got this kind of hole trapped. So pretty much we could probably draw in this boomerang that goes right there and have that done. Let's see what else we know. Y-intercept is at 1. Oh, that works out nicely because that's sort of what we would expect. X-intercept at 1/2. Even more information about this boomerang pattern, at least in that little piece of space. The only thing we don't know is, we probably got a boomerang either up here or down here. We're not sure which, but I'm willing to bet that it's on one side or the other, because all can be. And all we have to do is take, say, the number 2 and put it into this function. I would use this again because those will cancel out. It's just 3 over 3. So let's see. Let's put a 2 in. We get 4 minus 1 is 3. And 2 minus 1, 1. So at 2, we're at 3. Notice that kind of mirrors this point here, right? So look what we got. And then we got a half here, and that's a half. So I'm willing to bet that we got the same kind of thing going on there. But it's going to have to do something a little different. Well, here, we got the half here. So there we go. So that's pretty much where those boomerangs are going to be. All you got to do is kind of sketch them in now. We've got our hole. Anybody can do a better job than I do of drawing these things in. And that's it. On the final, I'll probably make sure that you have prompts for these things. What are you looking for? Rather than having you kind of come up with them off the top of your head. And that will make this a little bit easier. And then basically just transferring that data onto the graph. And that's all there is for problem 16. We're getting through this thing.